Hi guys, in this video I explain inheritance. I first go over the concept using a class diagram, and then I demonstrate how to implement it using the extends keyword. Let's take a look at the UML diagram on the right. This UML diagram shows two classes, class A and class B. Class A defines a single member variable named field A of type int. It also defines a method named method A. Class B defines a single member variable named field B of type int, and it also defines a single method named method B. The arrow in between these two classes defines an inheritance relationship. Based on this relationship, we can refer to class A as the parent class, or also called base class or superclass. Then B is the child class or derived class or subclass. These terms are interchangeable, so a derived class is the same as a child class or a subclass. Now it's important to note that this term doesn't describe the class itself. This term is really based on the inheritance relationship. That means if we had a third class, let's say class C below here, that inherits from class B, B would be the superclass of that class C. And B would still be a child class of class A. So it really depends on the inheritance relationship, not on the class itself. Now, what does inheritance actually entail? Inheritance means that the child class inherits many of the member variables and methods of the superclass. Let's take a look at this example. We have class B, and class B, due to the inheritance relationship, will have two fields. It will have the field B that it defines itself, and it will have the field of class A that it inherits, field A. So it will have both of those member variables, field A and field B. In terms of methods, it will also have two methods, method B that it defines itself, and method A that it gets from class A due to the inheritance relationship. So whenever we have an inheritance relationship, we inherit fields from the superclass, or at least we get access to some of the fields. That's why inheritance is also called an extension of an existing class, because we are extending and adding to the fields that the superclass defines. Let's take a look how this is done in Java. So I have two classes here. I have class A and class B. Now for class A, I will define the single member variable and the method. So it will have a member variable named field A and a method named method A. This method will simply output a statement, method A, and the value of field A. Now I have class B. Now in order to define the inheritance relationship, I use the extends keyword after the class name. Extends, and then I define the superclass, in this case A. Now this means that class B will extend A, or in other words, class B inherits from A. Now let's create an instance of B. I call this capital B object obj new B. Now when I do obj dot, I can see that I have access to the field A, even though this is not defined in the class itself. It really is inherited from the superclass. Now I can also access the method A. Again, this method A is not defined in the class B. It is inherited from the superclass. Now let's run this program. Now here we get the output, method A and 0. Note that this was really purely using class B. In our program, we didn't use class A at all. We declared a variable of type B and initialized it to a new object of type B. And then running this will run and execute the statements in method A, which is inherited from the superclass, and then output the default value for field A. Now let's extend class A with additional fields in class B. So here I define int field B, as I have outlined in the UML diagram, and a method named method B. Now in this method, I also output a simple statement, method B, and the value of field B. Now here with my object, I now can see I have two fields, field A and field B. At this point, I cannot really distinguish where they're coming from. The IDE here shows me that this is from class A and this is from B. But otherwise, they're really treated as if they were defined all in class B. And same with the method. I can now call method A and method B. Both will operate on the object B. Now running this, I can see that I can run method A and I can run method B. So why is inheritance useful? It is useful if we have a generic class that is really a blueprint for many objects, and now I need a specialized class. That specialized class has additional member variables or additional methods or some methods that work a little bit different. I would not want to rewrite the entire code, especially if class A is a very large class, many member variables, many methods. We always want to avoid code duplication. In this case, we simply use the extends keyword and we get access or inherit many of the fields that class A defines and many of the methods that class A defines. An example could be an animal. An animal really represents any animal that we can think of. And then I can have specialized subclasses that inherit from that animal class, such as a class named cat, or a class tiger, or a class dog. So I can create the different subclasses to differentiate the different types of animals. And I can use that just as to define the different types, but I could also then add specialized member variables or attributes and methods to the subclasses. For example, a fish can swim, but a dog doesn't swim. A dog barks. A cat meows. So all these have different ways of behavior and potentially different member variables. I hope you enjoyed this video and you get an understanding of what inheritance is and how to define it in code. Thank you for watching.